So our second last trick is algebraic factoring. So it's using algebraic factoring to simplify, which again, we covered in 7.1. We're just seeing it again. So if I look at this guy, the first thing I'm prone to do is simplify tan x, right? I want to change everything into sines and cosines, so I'm going to change it into sines and cosines. And it makes me feel like I've started. And you know what? There's half a mark, okay? So then, numerator. I'm going to look for my glaring identities. I've got a sine 2x and I've got a cos 2x. So I'm going to replace the sine 2x with the only thing it can be replaced with, which is 2 sine x cos x. And then I've got my denominator. I've got 1 plus cos x, and then I've got this plus cos 2x. And plus cos 2x always makes me nervous. And the reason why is that there's 3 options to choose from. So if I was trying to choose between these 3 options, if I chose option 1 and put it in here, I'd get a cos squared x minus sine squared x. I'd end up with 4 terms. That doesn't feel really great. Okay, so what if I put in 1 minus 2 sine squared x? I'd put in a 1 minus 2 sine squared x. If I did that, you know, again, I've got 2 plus cos x minus sine squared x. So again, I've got 4 terms, and that's feeling too complicated. So then I'm going to try the last one. And the last one was 2 cos squared x minus 1. Like, that one feels right. And that one's going to feel right because if I put in 2 cos squared x minus 1, not only am I being consistent and I've got a cos x and a cos squared x, so at least it's the same trig function, but I also have a 1 minus 1. And if I can make terms go away, it's making things simpler. So my numerator has sine x plus 2 sine x cos x. And my denominator would simplify to 1 minus 1 is gone. And I'm going to write them in descending orders of power. So 2 cos, actually maybe I won't. I'm just looking ahead as what it's going to turn into. I'm going to leave it as cos x plus 2 cos squared x. So I was going to change it, and then I looked, I was like, ooh, wait a minute. There's a 2 written second, and there's a 2 written second. I'm going to keep this order. Then I'm going to look at my numerator and see a greatest common factor of sine x. And I'd be left with 1 plus 2 cos x. In my denominator, I see a greatest common factor of cos x, and I'd be left with 1 plus 2 cos x. All right, now I know I'm on the right track because I ended up with a common factor, so this would simplify to sine x over cos x. And maybe now I just do a big like, yes, I did it. All right, pause the video and give this one a go. Okay, so in my numerator, I have a difference of squares. So I'm going to factor this as cos squared x minus sine squared x times cos squared x plus sine squared x all over sine x minus cos x. All right, I said ooh because I saw a glaring identity. This is going to simplify to 1. Then what am I left with? Well, maybe at this point I'm starting to look at the right-hand side and I'm like, ooh, negative sine x minus cos x. All right, I got too much cos and sines over here. So I see another difference of squares. So I'm going to factor that. I've got cos x minus sine x times cos x plus sine x all over sine x minus cos x. Okay, what am I going to do? Well, I'm looking for a common factor, and right now I don't have one. I have cos x minus sine x, and I have sine x minus cos x. I have to somehow make these the same. Well, if you remember, if I wanted to write any of these, either of these terms, in matching order. So notice how this one goes cosine and this one's sine cos. I'm going to make this one cosine. So this bracket would be negative cos x plus sine x. Now, if I greatest common factor out a negative 1, I'd be left with cos x minus sine x. In other words, I could rewrite this as cos x minus sine x times cos x plus sine x all over negative 1 times cos x minus sine x. Now I can see that common factor, that cos x minus sine x divided by cos minus sine x is negative 1. So now I would simplify this by saying I've got -1 times cos x plus sine x, or I guess the way this is written, it's cos x plus sine x divided by -1, but it does the same job, right? And we would end up with negative, now I'm going to write it in this order. So I'm going to distribute my negative sign through. I get negative cos x minus sine x, so I'm going to write it as negative sine x minus cos x. All right, so that's the factoring trick. I do want to take 1 second just to go back up to this question here. Okay, if you look at this question here, I did this one by creating a common denominator. I just want to show you that if I had done this one by recognizing that cos squared x is 1 minus sine squared x over 1 minus sine x, and this cos squared as well is 1 minus sine squared x over 1 plus sine x, I could have solved this one instead of having to create a common denominator. I could have factored to simplify. This would be 1 minus sine x times 1 plus sine x all over 1 minus sine x. And you can see now that that would go away. Minus, this one would be 1 minus sine x times 1 plus sine x all over 1 plus sine x. And then this factor would go away. And I'd be left with 1 plus sine x minus 1 minus sine x, which would give me 1 minus 1 is gone. Sine x minus sine x is 2 sine x. So, you know, every identity has more than one way to simplify it or to prove that it's true. So if you didn't like creating common denominators in part C, look for a different way. Look to see if you can use a glaring identity or if you can factor or anything along those lines. All right, good luck with this trick.